this video, I'm going to introduce the process of long division. Long division is a topic that you would have seen in Math 100 if you had taken that, but I wanted to run through it with you. All right, so I wanted you to compare a long division problem with rational expressions, which is what we're really trying to do, which is this, with just a normal long division problem like 4,945 divided by 21. All right, so I'm going to start with the numerical example, and then we'll go work on the one that has the variables in it. So when you're trying to divide 21 into 4,945, you really are looking at dividing 21. You really just kind of focus on how many times it would go into 49, or even just looking at how many times would 2 go into 4 to get a rough estimate. So 2 goes into 4 about 2 times, so we might estimate 21 would go into 49 twice. When you put it, you'd put it above the number 2, you'd put it above the 9. Now, after you do divide like that, then you're going to multiply 2 times the entire 21, and that would give you the 42. All right, now, at this point, you're ready to do subtraction. So you're going to subtract 42 from 49 and get 7, and then you're going to bring down the next number. And then we would continue that series of steps. So I'm going to jot those down. So the first thing we did was to divide. Second thing we did is and got the 2, is we multiplied, and I'm going to say multiply back to kind of remind us that we have to multiply that 2 times the entire 21. All right, the third step we did was to subtract, and we're going to add a little to that once we see it with the variables. So leave some room there to write a little more. And then the last step we did was to bring down the next number, next digit. Okay. Which was bringing down the 4. And then what we would do is just repeat those steps. Let me get that to go all the way. Repeat those steps. We'd go all the way back up here and do that again as many times as is necessary. So let's try this with the variable expressions. So we're looking at dividing k minus 2 into that entire polynomial, but we really can just focus on taking the 3k to the third and dividing it by k. So that would knock out one of those k's, and I'd have 3k squared left. So k would go into 3k to the third 3k squared times. So I'm going to put a 3k squared right there. Now, we're going to do the next step, which is the multiply back step. Now, that 3k squared is going to have to multiply back by the entire k minus 2. Just like when we took the 2 and multiplied back by this 21, we did by 21, not just by the 2. So when we do that, we're going to have to distribute here. And we would get 3k to the third minus 6k squared. Now that 3k to the third minus 6k squared is going to line up right here underneath their like terms. Okay. Now here's the part that's so much harder than when you just have numbers. Here's where you need to subtract, but you're subtracting this entire polynomial from what you had above. And if you remember when you were subtracting, learning how to subtract integers, like if I wanted to do 2 minus 5, we would do 2 plus a negative 5. We would change it to addition, keep, change. So here I'm supposed to be subtracting, but what works really well is to come in and say, well, I know that if I'm subtracting, that's the same as let me do it in a different color, as adding the opposite. And so what you can do instead of thinking of it like subtraction is you can say, if I'm subtracting that whole polynomial, then that would be the same as adding a negative 3k to the third. And then if I'm subtracting a negative 6k squared, that would be the same as adding 6k squared. So I'm going to suggest that you think of it that way. You do better when you're working with these integers if you can think about adding the integers. So I'm going to subtract by changing the signs and adding. Okay? So once I've changed the signs, I'm ready to think about how 3k to the third and a negative 3k to the third would cancel out. Then a negative 8k squared and a positive 6k squared would be negative 2k squared. When mistakes are made, it's usually right there. Right here is usually the trouble spot. It's because people will put negative 14k squared instead of subtracting a negative 6k squared. Now, once you've done that, then you're just going to bring down the next term, right? So it was bring down the next digit when it was numerical, but when it's got variables, we're bringing down the next term. And once we do that, we're starting this process all over again. Okay, so now for the second round, we're going to take the negative 2k squared and divide it by k. One of the k's would knock out, so we just have a negative 2k left. So I'm going to write that right up here above the k term. Then I'm going to multiply that negative 2k back by the entire k minus 2. So I'll be distributing negative 2k squared plus 4k. I'm going to write that down right here, negative 2k squared plus 4k. And then now I'm ready for that hard step where I'm trying to subtract that polynomial. So I'm going to subtract by changing the signs and then adding those integers. All right, so I like to see what the original sign was. And so when I change the sign, I usually write it above what used to be there so that I can tell that I've done it. Okay? And also if something doesn't feel right, I can go back and double check and make sure that I did what I was supposed to. Okay? Also, don't just make your work match what you know the work should look like. Just follow this process right here and let the signs change when they're supposed to at the right time, like as the process is happening. Don't be thinking ahead. All right, so now a negative 2k squared and a positive 2k squared would cancel out, and then a positive 3k and a negative 4k would be negative 1k, or negative k. Okay. Now I'm going to bring down the next term, which is a plus 10. And then I'm ready to go one more round. So I'm going to take the negative k and divide by k. And that's going to give me a negative 1. So that'll be right here. Notice it's at the end of the problem. Okay, so that tells me I'm finished. Okay, that'll be the last round I'll have to do. But I need to multiply that negative 1 back by the k minus 2, which will give me a negative k plus 2. So I'm going to line up that, the negative k plus 2, underneath the negative k plus 10, and then I'm ready to do my subtraction. So I'm going to come change my signs, and then negative k and positive k would cancel out, and a positive 10 and a negative 2 would combine to be 8. All right, now I meant to keep going back and forth from the numerical one to this one. Let me go back to the numerical one, though, now and just finish it up. So 2 would go into 7 more than 3 times, so I'm going to put a 3 there. When I multiply back, I get a 63. When I do my subtraction with the numbers, there's nothing hard about it there. It's just when you have the variables that it's difficult. Then I'm going to bring down the next digit and go again. So now I'm going to try dividing 2 into 11. It would go more than 5 times. And that's going to turn out to be 105. And then when I subtract, I wind up with 10. Now, this is the remainder. Okay, this right here is called the quotient, and this was the divisor. Okay, so the original problem that we had, let me write that down just a little bit. Okay, so this right here is the quotient. So that original problem we had, 4,945 over 21, okay, that is an improper fraction, and it's equivalent to the quotient plus the remainder over the divisor. It's just we typically leave that out when it's numerical, and what we do is we just write 235, we just write it 235. We say and 10/21, but we don't write it. Okay, so that's the long division process. You sometimes need to use long division when you're dividing polynomials. When what you're dividing by is like k minus 2, we could have used synthetic division. But if what you're dividing by had a squared in it, like if it wasn't linear, if it was k to the second or to the third power, we would need to use long division to do that. Now, let's think about, or let's write our answer over here, doing the same thing we did with the numbers. So that would equal 3k squared minus 2k minus 1. You need to write the plus on this one, the remainder over what you're dividing by, including the k. So over k minus 2. Okay? I'm going to do some more problems in another video.